Hello everyone, welcome back to Path for Cloud. So in today's video, we are gonna discuss Kubernetes priority classes. Before we jump into what is priority classes, we just need to understand what is priority, right? Priority is something where you just want to do that thing on top of other things, right? In layman term also, if we said understand the priority, so priority is something which will give you a more weightage apart from the other thing. So similarly, in priority in Kubernetes cluster also we have something called priority classes. Why? Because when we tired of unpredictable performance of your application, right? Maybe it is getting some downtime in your Kubernetes cluster, then what we can do is we can uh, get the help of this priority classes, right? Because it gives you a guarantee that your most important workload always gets the CPU and memory whatever they used. But how this magic happen, right? How this thing is being done inside a Kubernetes cluster? Who is responsible to make sure that okay, which workload is your critical, which workload is your non-prod, and the test and development, and similarly the low priority, right? Let's get a scenario. Let's say you have your cluster up and running where you have that master node and you have, let's say, five worker node. Okay, these are your worker nodes. Now your all workloads are up and running fine. On some bad day, what happen is your one of the worker node is down due to some hardware failure or something. Whatever the workload was running on that node, unfortunately that was the critical workload. Okay, and your cluster is already up to 80-90% is already used the resources. So now your critical workload was running on that node which is down now. What will happen to that workload? What will happen to that application pods which was running on the worker node? Scheduler will try to schedule those pods on the other four worker node. But since I mentioned we are already running almost out of our compute power. Almost we are almost running out of your CPU, your memory, right? So scheduler will is trying and it gets that okay, there is no sufficient CPU and it will get in the pending state. Now what will happen is you will experience a downtime for your critical workload. So in order to tackle this kind of scenario, we can define something called priority classes, right? Because this will help you to prioritize your critical workload and it can preempt the low priority workload or maybe the test and development workload, which can tolerate the delay, which can tolerate the downtime. But since this is a critical workload, so obviously it will get the high priority and it must be scheduled on top of all the other workloads, right? And how it will be done? We'll see in a bit. So let's come to our document-based definition of the Kubernetes priorities. By default, it's always high for Kubernetes cluster component, which is critical to run the cluster. Obviously, there are some components which we already understood, right? We have that etcd, we have that kube proxy, we have that kube API server. These are most critical component of your cluster. If those are down, you cannot interact with your cluster, right? So in order to run those, always we need to give a high priority to those resources. In most of the scenario, though, we cannot run any workload on the master node because master node is dedicatedly run for the cube Kubernetes cluster, these components, right? But somehow if you just remove that toleration and you have uh, scheduled the your workload on master node also, right? But in that scenario, always these get the high priority. Similarly, we can set the priority to avoid interruption by the lower priority workload. That's what we understood now. And we can do that with the help of priority classes, which helps us to define the priorities for different workload so that higher priority workload always gets a priority over the lower priority workload, which means if somehow a higher priority pod get killed or scheduler tries to start it again and due to some resource crunch, if it is not able to start, then it kills the lower priority pod. Obviously, it is not true in all cases because it defines something called preemption policy, which we'll discuss just in a bit. But this is a kind of default behavior we can see, right? What will happen is it will gonna uh, it will gonna kill the low priority workload so that the CPU or the memory will get free and your high critical workload get scheduled, right? So we have some like kind of range is defined for the priority classes. If I go to my cluster and if I just show you PI RESOURCS and if I just grep for priority, let's see PROI. So you can see that okay, this is a PC. Yeah, that's what I was looking. So priority classes is already a resource is there. This is the API and it is not a namespaced scoped object. Okay. So now if I run kget pc, so you can see we have our two priority classes already defined: system cluster critical and system node critical. So this is something that comes with your installation of your cluster, and these have a some higher value. So this range I was talking about, what you can see is priority classes are non-namespaced object. That's what we can see here. It is false. So they are available to be configured on any pod in any namespace, right? That's what otherwise what you need to do is you need to create a priority class in each namespace. But that is not we need, right? We need to be defined a one priority class and we want that priority class should be available across all namespace for each and every pod or maybe whatever the pod you want to define. It can define with the range from 1 billion to this value, whatever it is, like in negative something, right? Is for user hosted application or ports. This is the range defined for you. If you try to define a range for your priority class, uh, like outside of this range, it will not allow. It will give you an error, right? Because that is already set by the installation. But for the system workload, it is something 2 billion to 1 lakh. So from this range, somewhere you can set for the system related workload, which is a highly critical component for the Kubernetes cluster to run. And that's what we have seen. If you run this command, you can see that you have two already defined PCs, right? Now, when you run this, right, there is one thing that you can see that it is saying okay, as of now it is not saying, but here you can see kget pc, the preemption policy, right? It should show. That's strange. That doesn't make any difference, but still, yeah, not sure. But let's see, when we define our own priority, then maybe it will just show you the preemption policy. So what this preemption policy is, see, in this last statement, we have talked about if somehow your high priority pod get killed and scheduler is trying to do it, then what it can do is it can kill the lower priority pod and schedule your high priority, right? But that is not true always. That is something that you can control using preemption policy, right? Preemption is something to remove something, right? To in order to get something, you can remove other and you can get your thing. So what is preemption policy in Kubernetes? In Kubernetes, the scheduler decide which pods run on which node. That's true. When the cluster runs out of resource, some low priority pods might be removed to make space for higher priority pods. And this is called a preemption. That's what we talked about. The preemption policy field in the pod priority class control whether this preemption behavior is allowed or not. What this behavior is, whether that particular, though it is a low priority pods, but if it is the preemption policy is set to never, then in that case also your high priority pod will be in the pending state. It will not go and preempt your low priority pod. That's what it is saying. So you can see that we have two policies value, preemption lower priority, which is the default behavior. And what that behavior is, the scheduler can evict the lower priority pod to make room for this pod, right? That is a default behavior. But if you want a still lower priority pod to be up and running, you can set this policy to a never inside your pod. So what will happen is, or sorry, inside your priority class definition file. I will show you, so that what will happen is wherever that priority class is assigned to a particular pod, that pod will never get killed. Although a high priority pod is in waiting state. Never means the scheduler will not preempt. Preempt means evict any existing pod. Even this pod is cannot be scheduled. Right? That's what is the best practice, like when you need to use the priority class in which case scenario. So I just found something and I just thought to put here. So let's see what it is. Use priority classes for workload segregation, right? Obviously for system pod, application pod, test pod, that's what we are saying. If you have this category, if you want to you run a critical workload, then you can just define your priority classes and which will get the higher precedence across all other workload. That's what it is saying. If you have this kind of scenario or the environment which is almost already there in every infra, right? Then you can use a priority classes. Avoid giving all ports the same high priority, because if you give the high priority to each and every port, right, obviously then it is creating a kind of chaos, because scheduler will never know that which port it needs to evict and which it needs to schedule, because all are coming with the high priority. So whatever it is there, it will keep on running, and whatever we lost, that will keep on pending state. So always give a high priority to those application which is meant to be critical and up and running only. Use never for non-critical port that should not be interrupt others. That's what we understood, because never is something for the non-critical port that should not interrupt other. If they are not interrupting to any other, right, and if you want to test something for non-critical port, then you can define this never and you will keep on running. And always monitor schedule your events. That's what that you will see that okay how it is. Okay, now let's see what is the manifest file for this. So for this, here you can see what I have done is I am creating a two priority classes here. This is the API version we just saw here, this one, right? And this is the kind which we see, this one we have defined. The name is the prod priority and I am just giving the value is 1000. Range can be set from this to this. If you are going beyond this range or outside of this range, it will not allow you, right? Preemption policy, I'm just strictly mentioning that preempt lower priority. What it means is it's a default behavior always, but what we can just mention is if any pod which is set, assigned with the prod priority as a priority class, if that pod is not running, it will evict the other pod and try to schedule that pod, right? And this is not a true for the global default. That means that I want this priority to be set explicitly where I want to set it. Otherwise, there is no priority class for that particular pod. Whereas in the second scenario, I am just giving a non-preempting a policy, and I'm just giving a lower value for this, lower range for this. And this I am setting as a true, means if there is no value for the priority class is set inside a pod manifest file, by default, this priority class is being assigned to that particular pod. All right. So that is what the priority class is, and how you can see the priority class, right? So here we are talking about the default priority class which is already there. So let me show you one thing. If I just list our pod in the cube system namespace, right? These are the pod. Let's see for etcd master. If you describe this in the cube system, so somewhere we have this policy. Here it is. You can see that, right? For this pod, it is running in the cube system. By default, it is assigned to this policy system node critical, right? You can see that. And it has the value is this one. And due to the default behavior of your preempt lower priority, if something goes wrong, right, on this, let's say you have a multi-master node cluster and something goes wrong on that master, and your etcd is trying to come up on the another master node. If something goes wrong, or maybe something is not, then that generally does not happen, but I'm just giving you a scenario where you can understand that it will try to bring up this etcd port first. That's what this priority class and the priority range is. All right, so let's try to create now our policy. I will go to my lab. I think we have already yeah, we are already up to date. So I will gonna create this file called 61-1. So it is saying is that it is created a two priority class. One is prod priority and the other one is non-preempting. If we see now, you can see that non-preempting, it is saying a 900, and this prod priority is a value is coming as a 100, right? So this is something that you can see that whatever the priority classes you have. Now what we will do is we will create a two workload. One we will predict as a production workload which comes with this priority, and the other workload which we'll talk about, or maybe we'll consider it as a lower priority, and we'll see if all, because I have set that metric server, right? K top nodes. So you can see that current usage is this one, and I have that two CPU assigned to each node in my local lab. So we'll see uh, if we explicitly assigned a more CPU to that workload, so that we'll have a very less CPU for our prod workload. And due to this priority thing, we'll see in action if this evict the low priority pod and will try to schedule this production. All right. So here you can see this is the deployment for the dev apps, right? This is just nothing. It's just a simple development manifest file. Not development, sorry, deployment manifest file. I'm not specifying anything. What I'm just showing is I'm just saying that okay, each pod will get 100 milliseconds of the CPU and will have a 10 replicas of this. Okay, so let's try to apply this. K create hyphen F 61 file is number 2. So it has created. If I just show you the pod, so the pods gets created now, and it will gonna create a 10 replica of this, and each replica will gonna use 100 milliseconds of your CPU. All right. Meanwhile, it will create these deployment. Let's examine our second deployment manifest file. Here what we are doing is we are creating a 5 replica of our prod app. Whereas uh, I'm explicitly saying, okay, see here in this file, we are not defining any of the priority class, right? Let me show you first. If I just show you now, k get port, so you can see that we have 10 out of 10 is running. If I'm just defining any of the pod, k describe pod, let's see this one, and if I'll go up somewhere, so here you can see why? Because we are setting our uh, this policy, priority class policy is true. So by default, this non-prod development apps deployment is assigned this priority comes with a non-preempting 900. And we have set it to never. Never means that now we are out of running our resources, right? You can see that it is 96 millisecond already consumed, and we have already, maybe it is just the usage of it is saying, maybe let's see k describe node. If I just say k at node 1, and yeah, here you can see that it is the request, right? There it is not showing the request, it is showing you the current usage. So now if I just show you, so you can see that it has a 2 CPU capacity, and we have assigned a 10, so almost it is 1, and we have some metric server and VNet is running, so it is more than one CPU is already in consumed state, right? You can see that it is 1200 M, so only something 800 M or something is pending. Now what we will do is we will gonna create a second deployment where we are requesting a 250 M. That means that the 5 we need at least 20 to 1250 milliseconds of CPU for this prod application, and it is going to the prod priority, which has a something called preemption lower policy. And what this does is it will evict your lower priority pod, right? So now if I let me clear my screen, and if I just show you k get pods hyphen, let's count how many. It is 11. Why it is 11? Because it is counting the header as well, this line as well. So now we have 10 pods are already running, and we have this prod priority which has a higher value, and it is set to as a preemption policy, right? So let's see what will happen if I create 61-3, which is a priority class. It is created now. K get ports -w. Now you can see that it has terminated few from that low priority. Why? Because it has a priority to schedule a prod app. It is already terminated. Why? Because it was set to a preemption lower priority, which evicts the lower priority. And for the lower priority class, we don't have this preemption policy. So what will happen is, now if you see k get pods, so here you can see few are in pending state, and it will keep on pending. If I just say k get deploy, so here it will clearly show you you have that 5 are in pending state, because there is no CPU assigned left for this resources. But we have the priority set for our prod, and we have scheduled these workload later. Later means after the DevOps. Still, it has evicted these pods, and now it has scheduled our prod app. So that is the benefit of your priority classes if you schedule for any of the workload. So that the benefit you will get now. Now let's do one thing. Let me delete this k delete deploy prod app. Okay, and if I just show you now, it will schedule your dev apps now. In a few time, you can see that it has already started the scaling, because now we have the free resources which was assigned to the prod app, right? Now the prod app workload is deleted, and now we have the 10 out of 10 is running. So what we will do is now get PC. Let's delete this. I'll just show you one more thing. This non-preempting. It is already deleted. And now let's go. And this time I will say preemption policy is equal to never. And now we'll see that what is the behavior of this option. Uh, Okay, yeah, because that one of the policies already existing, right? So that is why it is crying. But anyways, now we have that two pieces again non-preempting, but this time it comes as a preemption policy set to never. Now, if you say get deploy, you have 10 out of 10 running. Let's deploy our priority class workload. And you can see that this will keep on pending state now. Maybe if it founds few, no, but it is again, there is something. Let me see. Maybe it is not preempting, non-preempting we have done, right? Let's one thing. VI61-1 and preemption policy we have set to never, non-preempting, and it is set to default. Yeah, because why? Because we need to, yes, now I got it what we need to do. Let me do one thing. Get deploy, delete, deploy dev apps, because that was already running, right? And that time was priority class was not set to never. Now we don't have any pods running. Now first I will create this 61-2, which is a priority class default.yaml. Okay. Now if I say we have 10 pod of running, get deploy, and it will soon run all 10 pod. 1, 2, and the rest 10 is also up and running in a few seconds. Now we have 5, 6, 8, 7, 8, and 9 and 10. Now we have all running, right? If just show you, it is 10 running. Now let's create the prod one, which is this one. And if I show you now, no, somehow it is not working. Never, maybe a typo or something. Let me see. Preemption policy is never right. It should not be, because that's what that never is. Never is saying the scheduler will not preempt any existing pod even if this pod is cannot be scheduled. So this never we have set, and the default one, let's see, get pods, and if I just say describe pod, and let's see this one, it is saying one insufficient CP because that was assigned to this, and it is coming with the non-preempting policy. And if I just describe our describe PC non-preempting DESCRI preempting policy never. This pod will not preempt lower priority pod. Well, this is, I think I did in a wrong way. Okay, now I got it. See, just pardon me for this. Let me quickly delete one more time and I will show you. Uh, Now it is deleted, and let me delete the not this one. Let me edit this. So this is fine. Now we don't have any ports. It is terminating fine. Now let's delete this priority classes. We will create it one more time. Okay, delete PC and the prod priority. Okay. Now I will go to our file, and this time I will set it to never, because we were setting that never, right? And that was already uh, what it a lower priority, right? But that we don't want. We want to set it for this one, where we want, though it is having a high priority, but we set the policy to never. That means that whatever the ports or the workload is assigned to this priority, they will not gonna preempt another workload, right? That's what the behavior we want. So let's quickly create this. We have created. Now let's quickly create our this one and get deploy. Let's wait to come for all the 10 replicas up. Because sometimes when you do it right, then only that you will experience it. That's what I was saying. If you are following along with me, then it is a recommendation, it is a strong recommendation. Clone this repo inside your local system. If you are not able to set this lab, right? So for the operator, we have used an online lab where we get the 60 seconds, 60 minutes of lab for from the killer coder, right? That playground you can use, and you can play with all these demos and everything. Okay, now we have our all 10 replicas up and running. Now I will gonna deploy my third, and this time it should know. Now you can see that it will keep in pending, maybe one or two, but it will not uh, remove that any of the dev app. Let me run it one more time. You can see we have this, right? If you just run that get pods, you have this in pending state, which is the prod app. If you describe this, here you can see insufficient CPU. Why? Because this is having a high priority, right? But it is coming as a never preemption policy. Though if any of the port gets deleted from this, and if there is another set of workload is already in a pending state, on top of that, the priority will be given to this workload where this priority class is set. That's what the current scenario is. But it is set to never, so by default it will not gonna evict any other port which is already up and running, right? That's the different behavior of your preemption policy. All right, so that was the preemption policy in our Kubernetes cluster, which can help you to uh, expedite or maybe prioritize your critical workload on top of the other workload. All right. I hope this is something because I don't have anything to explain in this. We have gone through all our demos and the definition of this what do you call it, that Kubernetes priority classes. Okay. I hope you found this information helpful. And if yes, then I would request you to please hit that like and subscribe button, and we'll meet you in the next video where we will probably will see that what is the next topic. I can see that maybe we'll just gonna discuss the something called Uh, yeah, maybe we can this admission controller we can see if we can discuss this. Yes, we will gonna discuss the admission controller in the next video. Until then, uh, if you are following up, then please clone this repo inside your because the latest code is already pushed to the repo and it is there to clone, and you can follow along with me to get your hands dirty. All right, so I will meet you in the next video, guys. Till then, stay happy, stay learning, and I will meet you next. Thank you. Bye bye.